So I'd like to introduce our first speaker, who is Ralpf Watzel. He's a German hydrogeologist and president of the Federal Institute for Geosciences and Natural Resources, BGR, which is under the Federal Ministry for Economic Affairs and Climate Action. Welcome, Ralph.
Yeah, thank you, Julia. You put it right. It is the question, where is what? It's the power of spatial information, traditionally in 2 dimensions, and nowadays in 3 or even 4 dimensions if we consider time. And our situation in Europe is that we have done that for the last 100 or 150 years in a descriptive way on a national basis. So we are faced with a bunch of individual descriptions of same or similar issues and features in the subsurface. And in Germany, we have a very particular situation. We have a federal political system. And for the last 160 years, the geological surveys were organized on that level, where we are still today. So as a federal institute, I have 16 regional geological surveys in my back. And they have their independence and their knowledge. And the challenge is to bring it together. And how do you bring things together that evolved over more than a century? And I think that's why I'm invited here to talk on that, because that's a mirror situation in EGS. And as we are dealing with that traditionally, so we made some serious progress. And in the past, it was the standard way of compiling maps. We are able to compile maps. And there are remarkable achievements in the past on the national and on the international level. And that follows a certain procedure. And this is like bringing experts together, fencing them in a room for a year or sometimes 15 years. And they have heavy discussions on matching the units, the legend units, or the geological issues they are dealing with, they are describing. And I've seen fierce fights about, does unit A in country X match unit B in country Y? And this is with goes together with the self-understanding of the mapping geologists. If you have invested so much work, and if you spend months and years under the rain and the wind in the field, and you are proud of your work. And this is also a psychological perspective, how to bring it together, how to match it with the work of other people. As I said, there are remarkable achievements, and I don't want to criticize them, and we have to keep on track going that way, but there is room for more, and there is also a need for more, because the traditional way, honestly speaking, is not very efficient. And here is where the new technologies come in. And I want to give you an example of what we are doing in Germany, how we approached that challenge, and how we cope with it. Maybe I can switch the microphone. This one, A, B, C, D. That's fine? Okay, so I can see the slides. No? No, it was. Okay. Okay, engineer. Yeah, just watch the figure there. It represents, let's say, the breaking lines along the political or administration borderlines, and we have to bring that together. And typically, what we have, the work of generations of geologists that doesn't fit together in a compatible way, and the main objective is to provide harmonized interoperability of integrated data sets. Okay. So we set up a pilot project in southern Germany with the regions of Baden-Württemberg and Bavaria, and inspired by the BGR. And the goal was to link the general legends of the two countries. They have a region covering a digitized map that is harmonized, well, both are harmonized in themselves. and we are heading for a trans-border harmonization of the 1 to 25,000 scale of that two regions. And then after having done that, we want to proceed and do a machinable downscaling to the 250,000 or 500,000 scale. And this is where the BGR comes in to provide Germany-wide covering data sets. And then in the third step, we want to link that, to the stratigraphic standard of Germany, the so-called lithostratigraphic lexicon. This is a precise, detailed, science-based description of all geological units. How to do it? I got inspired from our geodata manager that has unfortunately left us, and she was talking about applying the technologies of the so-called semantic web. So for those who are not familiar with semantic web, it means putting an expression into a precisely defined context. So Berlin may be a city, the name of a ship, a nightclub, a chess band, and defining that precisely, that is the principal idea of the semantic web. We wanted to assign unique and persistent labels in the internet wording that's a uniform resource identifier to the general legend units, and we want to define relationships between the units in region A and region B, because this is where the dispute between the geologists is located. And we wanted to do that by a triple structure in the so-called RDF language, the resource description framework respecting the stratigraphic or geological hierarchy. And it's simple. It's that what you know from your English lessons. It's subject, predicate, object. Nothing more. So you have two nouns, and the subject and the object, and you define the relationship. That's the predicate. In geological terms, it looks like this. We have a geological unit A in region X, let's say Upper Jurassic, and a geological unit B in region Y, let's say Upper Jurassic. And the question is, are they identical? Or are they similar? Or is one subordinated to the other? Or do they have any relation at all? So, and we set up a workflow. So what we did, we matched the geological legend of the two regions from the 1 to 25,000 scale with that scarce relations to an overarching generic legend. We did it in the pilot area, the first results were promising, and then that was the work matching 1,800 legend units on the one side and 3,300 legend units on the other side. That was the work for two geologists done in 1 month. If the mindset is okay, if it's open and they are committed. So, and next we can do this downscaling, we come back to that later, and this is just an idea to give you a picture to give you an idea how that is implemented. It's implemented in a software, and the name of software is Pool Party, and we run that in the BGR, and all the rest is done over the internet. So here, that's a screenshot from the GUI of Pool Party, and on the left-hand side you see the legend units, the formations, some information about the matching process, and if we zoom in, I want to have this one, you can see the hierarchy. So if you can't match that formation here exactly with the other, we do it on the next hierarchy level. And if that doesn't work, on the next hierarchy level. And in the end, you match Mesozoicum to Mesozoicum. Yeah? And this is what you see in the 1 to 5 million. Okay. Left-hand picture where we started, right-hand picture where we ended up. So today we have a 1 to 25,000 of Baden-Württemberg and Bavaria, and this is 1/4 of the surface of the Federal Republic of Germany with one unified legend. And to be honest, there is a loss of information. And there's a loss of information in the order of 5 to 10%. And if the next step is upscaling, that loss of information is completely irrelevant. So, and that's one example here. We've choose a pilot area. This is close to Frankfurt City, Baden-Württemberg and Bavaria. And you see the original over there, the 25,000, and then the downscaling by an algorithm that is self-learning, that can be customized down to the 1 to 500,000. And we do that at the moment in an open source process. So we have a contract with the guys in Baden-Württemberg. We work on that and we give feedback to improve the algorithm. Yeah, that's my conclusion. That's my summary. The implementing and applying the technology is very, very promising. The downscaling algorithm is even more promising. And for that reason, the directors of all geological surveys in Germany have decided in fall 2022 to roll it out over entire Germany. So my thinking is about, the name of the project is Consent, and my thinking is about a soil consent, a hydro consent, a raw material consent, and whatever. Thank you for watching.